Most fine-tuning tutorials end the same way. A file only their own framework can read. This one ends in llama.cpp. 3 minutes. Teach a quantized Qwen3 a new style on a laptop CPU, then export a standard GGUF that any GGUF consumer can serve. Why not full fine-tuning? Qwen3 0.6b is 595 million parameters. Atom W bookkeeping alone runs to gigabytes. And the file you actually have is quantized. In Fucina, quantized weights are constants. No gradient state, a type-level fact, not a convention. So Lura goes around the wall. Freeze the weight, train 2 thin factors beside it. B starts at 0, so at step 0 the adapted model is the base model, exactly. Rank 8 on the Q and V projections, 1.15 million trainable parameters, about 0.19% of the model, and optimizer state in megabytes. The demo dataset is 5 pairs. Every answer opens with a HOI. Gradients flow to the F32 activations only, backward multiplies by the frozen weight. It never updates it. So the base stays in its Q4KS blocks while a few megabytes of adapter train. 30 steps later, loss falls from 5.77 to 2e-4. That is memorization on purpose. The point is the whole pipeline closing in under a minute of laptop time, and the after generation opens with a HOI. Now the loop closes, 4 commands. 1. Fine-tune over the dense F16 base and save the adapters. 2. Merge them into the weights. This is the only place B times has ever materialized. 3. Quantize the merged file to Q4K. 4. Serve it. In Fucina or in llama.cpp, which has never heard of any of this. Merge and quantize are separate passes by design. A quantized base refuses to merge because every extra trip through a quantizer compounds error. The exported file carries exactly 1 quantization in its history, and the repo's claim is tested. The merged model answers in the tune style under llama C, L, I, and loads in llamabench as Q4K small. And if fine-tuning feels like borrowing someone else's weights, the tree holds an existence proof. Karpathy's nano chat, ported whole. Tokenizer training, GPT per training, supervised fine-tuning, bits per byte eval, and chat with a calculator tool. From scratch on CPU, verified against the Python reference. Token-exact tokenizer, byte-identical loaders per layer forward parity. It's a small GPT, 6 layers, 384 wide, and nobody pretends otherwise. That is the honest shape of CPU training. Fine-tunes of real models, small models on your own data, determinism-first research loops. It is not pre-training at modern scale, and the docs never claim it is. After pre-training, gradients, evolution, triplanes, or a trained context. Formats, not frameworks, are the interface. Next time, the craft, how a library like this earns your trust.